how do you go about acquiring data and then doing its analysis? So for our case, you could be the centralized team which is working across different locations would be collecting data from these different factory locations. It would then annotate the data, verify with experts, and once they have good, clean, annotated data, they would subsequently use it for model training and testing. But there are certain challenges, and these challenges have to do with the fact that most industries they use a control device called as a programmable logic controller, or PLCs. And these PLCs have been around for around 50 years or so, and these PLCs do not have the ability to store data. Okay. Second challenge is that usually we don't have a large amount of data to work with. This is quite distinct with the IT data. Since deep learning models, in fact, most of us think that deep learning models require large quantities of data, and that is because these large quantities of data, there is a lot of noisy data in this large quantity. And to basically suppress the noisy data, it is required in large quantities. In this case, since industries have lesser quantity of data, we can compensate for the quantity by now putting more emphasis on its quality. Okay, so now we have a smaller quantity of data. We can make sure that it gets labeled correctly, it is validated from experts, and this is how we could get away with a small quantity of data and still get acceptable accuracies as we would earlier get with large volumes of data. And the third would be that if you don't have any data to start with, because there is very less data in the public domain that pertains to industrial data. You can get data on everything else, but very few industries have data to share in the first place, and there are very few industries who have data and they are willing to share it in the public domain. So usually the job of the AI team would be to instrument or to get or acquire data in the first place. So when they go about to set up instrumentation for acquiring data, they have to keep in mind finer details such as the ambient light in that work cell, what kind of moving object they are trying to track for object detection, or they have to filter any kind of background noise when they do audio applications. So these are finer aspects that they have to keep in mind when they go and create a data acquisition system. Now, once they come back with the data from the factory, or they may have some team in the factory which is in fact providing them this data, they would have to, first of all, when they get the data, they should first of all visualize the data, and they should ask the factory people how the data set was constructed. Okay, and also they should consult an expert for data pre-processing. So before they filter out any sound, they should find out whether that sound was important in the first place. So they should not be filtering sounds which could have a large role to play. And if the model starts giving very high accuracies early on, they should be skeptical about it, because if they see that the model is performing very well, they should ask themselves, is the model memorizing? Because models, just like electric current, take the path of least resistance. So these are certain sanity check, certain questions that should raise red flags if they see the model performing very well or very early on. Okay. So let us take this example. How would you do audio data pre-processing? So since we have been talking about audio, about this sound which is being created when the car is getting tested, so the car would be instrumented, that particular test cell would be instrumented with multiple microphones, and all the microphones would be capturing these audio wave files. So the job of the pre-processing system would be, first of all, to filter any kind of background noise, and after that is filtered, it would basically trim the wave file into small duration wave files. Suppose you have a wave file of 5 minutes, so it would basically trim it down to 1 second each or 5 seconds each. And once the wave file has been created into smaller time durations, it would get converted into spectrograms. And these spectrograms are basically images. They would be in the form of a PNG image file. And we would use the concept of image classification. So the image classification models can now help us do audio classification, because now the sound has been converted to an image. So how do we go about doing that? So if you see in this particular slide, there is a software called as SOX, which basically is for sound exchange, and one could use the SOX software for filtering sound and for creating a spectrogram. So as you see, for this for the first CLI command, in this we have a sound coming from a trumpet, and that trumpet sound gets filtered using a low pass filter of 3000 Hertz. So as you see on the right hand side is the original trumpet sound, and what you see on the left hand image is the filtered trumpet sound. Okay. So after this has been filtered, we would then create a spectrogram. And as you see that, we can give the spectrogram size of the image that gets created for the spectrogram. We in this case we have chosen it to be 224 x-axis and 224 y-axis, because this is the size of the image that is used by most classification models. For the second case, we have the same operation, but now this is being done on the waveform which is not filtered. So in this case, we have created a spectrogram which is a kind of a fingerprint for a trumpet sound, and we can now feed these images to our deep learning model such that it learns to recognize this kind of an image and would learn to associate it with the sound of a trumpet.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Rahul's webinar, Connecting AI to IoT Applications, whenever you want by heading over to our website www.doulos.com/OD and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.